This is the first of two videos introducing our properties of limits. Sometimes these are called limit rules or limit laws. Our first one is the limit of a constant function rule. This rule says the limit as x approaches a of c is equal to c. For a lot of these limit rules that we have, I like to think of them in terms of words. I think it's easier for me to remember them, so you might find that as well. So our first rule here says that the limit of a constant is that constant. And that kind of makes sense for us because if our function is just a constant, then the graph of that function is going to yield a horizontal line. And no matter what x value we're at, the y value is always going to be that constant value. So let's find the limit as x approaches -2 of 1. Since our function is a constant, our limit is going to be equal to that constant value. Our limit's equal to 1. Our next rule is the limit of the identity function rule. Our identity function is the function y equals x. This rule says the limit as x approaches a of x will be equal to a. In the identity function, the y value equals the x value, so as we're approaching a particular x value, that y value will be the same. Basically, we're just taking whatever this number is and plugging it in for x. So the limit as x approaches 436 of x. We're just taking this 436 and plugging it in for x. It's going to make our limit equal to 436. Our next couple rules combine multiple functions. So let's suppose that c is a constant, a is a real number, and the limits as x approach a of f of x and the limit as x approaches a of g of x both exist. Here we have our limit of a sum rule. It says the limit as x approaches a of two functions being added together, f of x plus g of x, is equal to the limit as x approaches a of the first function plus the limit as x approaches a of the second function. That is, the limit of a sum is the sum of the limits. I think of it kind of as like I'm distributing the limit to each function inside the parentheses. Let's find the limit as x approaches 6 of 8 plus x. So I'm going to distribute in. Now, of course, distribute is the wrong mathematical word, but that's just kind of what I think of when I see this. I'm going to apply that limit to each term in the parentheses. This becomes the limit as x approaches 6 of 8 plus the limit as x approaches 6 of x. And now we're going to find each of these individual limits and then add their answers together. Our first one, we have the limit as x approaches 6 of 8, which is a constant. So using our constant rule, we get just 8. Then we need to find the limit as x approaches 6 of x. Here we're using our identity function rule. And this 6 just gets plugged in for the x, and we get 6. The limit as x approaches 6 of 8 plus x is 14. Similarly, we have a limit of a difference rule. It's basically the same thing. If you have the limit as x approaches a of two functions that are being subtracted, this is going to be the limit of the first one minus the limit of the second one. That is, the limit of a difference is the difference of the limits. We just apply this limit to each one of our functions. Let's find the limit as x approaches -3 of x minus 9. The first thing I'm going to do is rewrite it, applying the limit as x approaches -3 to each part. And just be careful here when you write the second part, it's just going to be 9 because the minus in between the terms is the minus that I have in between the two limits. So don't double count that negative. The limit as x approaches -3 using our identity function rule is just -3. And then the limit as x approaches -3 of 9 using our constant function rule is just 9. Therefore, the limit as x approaches -3 of x minus 9 is going to be -12. Our last example here, I like this question. I like this for a test kind of question. Suppose that the limit as x approaches 4 of f of x equals 10, and the limit as x approaches 4 of g of x is equal to -3. We want to find the limit as x approaches 4 of g of x minus f of x plus 6. We're going to take this one limit and break it up into 3. Applying this limit to each one of these terms, this becomes the limit as x approaches 4 of g of x minus the limit as x approaches 4 of f of x plus the limit as x approaches 4 of 6. We'll find each individual limit, and then we'll add and subtract those answers together. The limit as x approaches 4 of g of x, well, there's not a limit law for that, but they just told us what it was. They said that this limit was equal to -3. Now, the limit as x approaches 4 of f of x, they gave that to us as well, 10. And lastly, we have the limit as x approaches 4 of 6. The limit of a constant is that constant. So we have -3 minus 10 plus 6. Our limit is equal to -7. In the second part, we'll talk about more of our limit rules and how to combine them.